Okay, so in today's lecture we're going to talk about two functional groups, which is amines and amides, and these are the nitrogen containing compound, nitrogen atom containing or we can say organic compound. So why we need to study about these amine and amide that has a nitrogen atom in it or a nitrogen containing compound? Because many nitrogen containing compounds are important to life, because this is present as a component of amino acid. You will see these compounds are present in amino acid, proteins and nucleic acids. And we know nucleic acids are two types: DNA, deoxyribonucleic acid, and RNA, which normally contain our genetic information. So these compounds are important, and then we're gonna learn about each of them separately. So let's start with amines first, and then we'll go to the amide. So what are amines? Amines are a derivative of ammonia where one or more hydrogen atoms have been replaced by an aromatic or alkyl group. What does it mean? So we know this is ammonia, NH3, and we have a lone pair on nitrogen, and then this is ammonia, right, NH3, and we can just extend the we can just form the expanded structure of ammonia the way it is over here, and we have 3 hydrogen attached to the center nitrogen. If I remove one of the hydrogen and replace with any alkyl group R, then it becomes amine, right? If I remove, I can also remove one of the hydrogen, because we have 3 hydrogen. If I remove with another R, which is R prime, then again this is one of the amines. And then if I remove the third R and then replace with any other R prime, then this is also an amine. So basically amines are normally formed if I remove 1 or 2 or 3 hydrogen from the ammonia molecule, right? So so amines can be classified. So now we'll see how we can classify the amine. Amine can be classified on the basis of molecular structure. So we'll see. So the first one is amine, primary amines. Primary amines means only one of the hydrogen from the ammonia atoms get replaced by one alkyl group or aromatic group. For example, RNH2. So what's happening over here? One of the hydrogen from the ammonia is get replaced by any alkyl or aromatic group. So that's why it's primary amine. Only one hydrogen atom is removed or replaced. Secondary amines are those amines where you have 2 alkyl group on the nitrogen atom, which is R2NH. For example, this is amine, then one of the R group and second R group, R dash. So out of the 3 hydrogen that is present on the ammonia, 2 get replaced by 2 alkyl or aromatic groups. So this is secondary amines. The third one is tertiary amine, where all the 3 atoms on the ammonia get replaced by 3 alkyl group or aromatic groups, right? So for example, this is nitrogen. Now you have 3 alkyl group, maybe same, maybe different, but they get replaced by the alkyl group. The hydrogen get replaced by the halide group. If you can see over here, the nitrogen is attached to 3 alkyl group, directly bonded to 3 alkyl groups. So this is a tertiary amine. So make sure you know how to differentiate between primary, secondary and tertiary amine. It's almost same as primary, secondary and tertiary alcohol, how to differentiate between the structure of alcohol that we already discussed in alcoholic chapter, where we discuss alcohol. So similarly for amines is again how many carbon or alkyl bond is attached directly to the nitrogen atom. So this is a table that you can see what is primary amine, secondary and tertiary amine. This is a general formula. Here nitrogen atom is directly attached to 2 hydrogen and 1 alkyl group directly. So this is primary amine, and one of the example is CH3 is attached directly to the nitrogen and you have 2 hydrogen. This is one of the examples. Secondary amine, nitrogen is directly attached with 2 alkyl group and 1 hydrogen. Example, in this case you have 2 methyl group attached to the same nitrogen directly bonded and you have 1 hydrogen. Tertiary amine, you have nitrogen, you have 3 different alkyl group, maybe same, maybe different, but you have 3 different alkyl group directly attached to the nitrogen atom. So you have nitrogen, for example, nitrogen attached with 3 methyl group in this case, right? So make sure you know how to differentiate primary, secondary and tertiary amine. So let's try to do a couple of problems to figure it out whether the organic compounds are primary, secondary or tertiary. So let's start with the first organic compound, which is CH3 and H and CH2 CH3. Second one, you have nitrogen and then you have a bond and then this is hydrogen. The third one is you have a benzene ring, you have nitrogen attached to the benzene, now you have CH3, you have CH3. So now let's try to figure it out whether all these 3 compounds, nitrogen containing compounds or amines, are primary, secondary or tertiary. So let's try the first one. You have a nitrogen atom and you have 2 alkyl group attached to this nitrogen atom completely. So this is one of the alkyl group, R1. This is second alkyl group, R2. So out of the 3 bonds that nitrogen can make, 2 of them are directly attached or converted to a alkyl group. So this is secondary amine, or you can write secondary amine. Okay. So let's try to do the second one. You have this nitrogen atom in a cyclic ring and this nitrogen attached to one of the carbon over here. This same nitrogen bond is attached to the second carbon and the third bond is attached to the hydrogen atom. So out of the 3 bonds, 2 bonds have been replaced by alkyl group, basically with carbons. So this is also a secondary amine. What about the third one over here? So you have a benzene ring. On benzene ring you have N nitrogen atom attached, and on that nitrogen atom, out of the 3 bonds, 1 bond is already attached to the benzene ring, 2 others are attached with methyl group. So that means all the 3 bonds of the ammonia or the amine have been replaced by 3 alkyl groups, right? So this is tertiary amine. So make sure you know how to differentiate between secondary, primary and tertiary amine. That will be really helpful while you're doing some reaction later on in this chapter. So now let's try to understand how we names and any nitrogen containing compound, especially amines. So you have 2 different names or 2 different ways so that you can name amine. One is common name that we commonly use, and second one is iopic name, which normally we use as a scientific way of naming an amine. So let's start with a common name first. Let's start with common name. So how you name amine as a common name? So you have to see how many. Let's take this example over here. So or let's go to the step. So the first, you have to see alphabetically link the name of the alkyl and aromatic groups bonded to the nitrogen atom. So that means you have to see how many alkyl group is attached to the nitrogen atom and what their alphabetical orders are. Second, attach the suffix amine so that the name is one word. So your ending word for any amine containing compound is always amine whenever you name, and use di or tri prefix if you have more than one identical alkyl groups attached to it. So let's take couple of example and try to understand this step. So this is the first example. Here you have nitrogen atom, and this nitrogen atom is attached to two hydrogen atom directly, and one of the bond is attached to an alkyl group, R group. So how we name? You have to just name the alkyl group. This is methyl, one carbon, so this is why this is methyl, and then the ending word will be amine, so methyl amine. So let's take second example over here. Same nitrogen atom directly attached to three groups. One of them is hydrogen and two other groups are methyl group. I can draw the same structure like this, and hydrogen, right? Exactly the same structure. So out of the three bonds, two bonds are attached to two alkyl group. In this particular case, both the alkyl groups are methyl. Right, so that's why we are writing dimethylamine. Let's try the third one over here. You have nitrogen atom attached with three bonds with three atoms. One of them is hydrogen and two of them are alkyl group. This is methyl group, this is ethyl group. Now how are you going to name? For this amine you have to use alphabetical order. Why? Because both of the alkyl groups are different. One of them is methyl, another one is ethyl, so you have to use alphabetical order. Then ethyls comes first, then methyl, and then at the end you have to write amine. So ethyl, methyl, amine. Right. Okay, so make sure you practice this kind of naming of organic compound or for amine. Now let's try to understand how we can write the iopic name for the amine. So it will be exactly the same that we have been using for naming of any alcohol, alkane, alkene. So you have to give the preference to the amino group. First you have to find the longest continuous chain, which is called parent chain, right? That we have been doing for the last couple of chapters. Find the parent chain first, then give the priority to the functional group. In this case, what's the functional group is amine, NH2. So you have to give the lowest number to the amine, to the carbon that contain that amine, right? And at the end the wording should be ending with amine, right? And if you see any alkyl group attached with the nitrogen atom, then we have to use an suffix. This is called prefix, which is N, right? So we'll see some of the example where we're going to use the N as a prefix. So let's do a couple of example over here. So let's do the first one. So now you have amine over here, and then what should be the longest chain? We can see easily this is the longest chain, carbon containing chain. So we have to write the number so that this amine group, our functional group, should get the lowest number. So we have to start from here, 1 2 3 4 5, and on the second carbon we have amine, so we can write 2-pentamine, right? Because we have 5 carbon, 2 pentane and amine. So this 2 is telling us that the amine group is present on the second carbon. Right. Let's do the second example over here. The time I see the carbon containing chain, so this is amine and this is the corner carbon, so I have to give this as a priority because this is a corner carbon, this has the functional group attached. So this is 1 2 3. Now I can go up or go straight, it doesn't matter in this particular compound because both of them have just one extra carbon if I go up or go straight. So I am going to go straight. This is 4. So how are we going to name it? So on the third carbon you have a substituent 3-methyl. On the first carbon you have the functional group, so 1-butanamine. Even though if you don't write 1, it's okay, because if you don't write any number, that we assume that the functional group is present on the first carbon. So this is 3-methyl 1-butanamine. This is the ending word, amine. Right. Let's do the third problem over here. Now you have the nitrogen atom Now the nitrogen atom contains 2 alkyl group and 1 hydrogen. So this nitrogen atom has attached to 1 hydrogen atom, 1 methyl group and 1 this long carbon chain, which is second other alkyl group. So what you need to do, you have to pick the longest carbon chain. If you have multiple alkyl group attached to the amine, so you have to choose the longest carbon chain. In this particular case, this is the longest one. So this is corner carbon, this is corner carbon. So where you need to start counting? From this end, right to left, because the second carbon will have our amine group, NH group. So 1 2 3 4. So if it's 4, we know this is butane amine, and on the second carbon we have amine group. So that is why this is 2 butane amine. But we have to also include the name of this methyl group. So you have to write a special prefix, which is N. This N normally indicates the alkyl group, whatever the alkyl group. In this case, this is methyl. This methyl group is not part or is not attached to the parent chain, but it's attached to the nitrogen atom directly. So this N normally tells you alkyl group attached to the nitrogen atom, right? But not on the parent chain. Right? So that's why we usually write N, that will specify this alkyl group attached to the nitrogen atom but not on the parent chain. So make sure you know this difference whenever you have multiple alkyl group attached to the nitrogen atom, like we had in this one. Okay. Now we'll see how we can name an aromatic amines. That means if you have a benzene ring and if you have amine group attached to on the top of it, or you can say one of the hydrogen is get replaced by the benzene ring. So you have N and one of the hydrogen get replaced by benzene. So we have a special term for this compound, benzene with an amino group. We call this compound as aniline. So this is a common name, but we can use this name is in Iophic nomenclature or scientific nomenclature. So make sure you know this structure with a name, what is aniline is. Okay. Now exactly the same thing. If you have any other alkyl group attached to the nitrogen atom, because in this case on this nitrogen, one of the hydrogen get replaced by benzene ring, but still you have 2 hydrogen attached to the nitrogen, right? And we already know this is a parent chain, this entire thing, which is aniline. But this nitrogen atom still has 2 more hydrogen that can be replaced with 2 more alkyl group, and that alkyl group is gonna be a substituent alkyl group, not the parent chain. Parent chain will always be an aniline, right? So we have to specify by writing prefix N of that alkyl group, N alkyl, because we have to tell the reader that this alkyl group is attached to the nitrogen atom, not on the parent benzene ring, anywhere on the benzene ring, right? So this is how we differentiate. So let's try one example over here. So let's take a simple example first and then we'll do this example. So let's try to name this molecule. This is NH2 and this is Br. So what should be the name for this molecule? So the time I see benzene ring plus NH2 group attached to it, I know this is the parent chain, this is aniline, right? And now you have to start counting the number on the benzene ring from that carbon that has the amine group attached. So this is 1 2 3 4 5 6. So the name will be 2-bromo aniline, right? Now let's try this example that is given in your PowerPoint. again the time I see you have a benzene ring, and on benzene ring you have amine group attached, and for amine, one of the hydrogen out of the two hydrogen that we had for aniline, one of the hydrogen is get replaced by one methyl or any alkyl group, right? So even though this is aniline, but one of the hydrogen is absent, and that hydrogen get replaced by one alkyl group. So how we name this molecule? So again the same, you already know this is aniline. You have to give this carbon number that has the functional group NH number 1. Now you have to go 2, 3, 4, 5, 6. So that means you have 2 ethyl group is attached on the benzene ring on the second position, and then this entire compound is aniline, but what's missing? This methyl group, because we have to include this methyl group, and this methyl group is not part of the benzene ring. It attached to the nitrogen atom. That's how we have to write N, a prefix that tells us that there is one more methyl group that is present directly on the nitrogen atom, not on the benzene ring. So N-methyl aniline, right? So make sure you practice this kind of problem. Let me give you one more example on this. This is benzene, this is nitrogen attached to it, and you have 2 hydrogens. So I know this is aniline, right? Benzene plus NH2, aniline. But if I replace one of the hydrogen with, let's say, CS3, and let's say if I remove the second hydrogen too with an CS3, so how are you going to name this molecule now? Even though the parent chain still is aniline, this is a parent chain, but how are we going to name it? So we're going to name, we have to write the prefix. So let me remove this name. I can write N, 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 dimethyl aniline. I can write this name because on the same nitrogen atom you have 2 alkyl group attached which are same. So this is also methyl, this is also methyl, so that's why each end represent that you have 2 methyl group and both of them are attached to the nitrogen atom. That's why we have to specify 2 times, like we usually do for aliphatic hydrocarbons, like 2, 2 dimethyl. Similarly for this case we're going to use N, N dimethyl. That means both the alkyl group attached to the nitrogen atom of the aniline, not on the benzene ring. So N, N dimethyl aniline, this is the name for the compound. So make sure you practice this kind of thing where you need to put N and where you don't need to put N as a prefix. Right? So now let's talk about the physical property of the amine. So simple and low molecular weight amines are gas and room temperature, whereas heavier and more complex compounds are liquid and solid because of the hydrogen bond. So NH bond is not as quite polar as OH bond. What does it mean? Because between nitrogen and oxygen, oxygen is more electronegative. Electronegative. I can write like this over here. Electronegative. So if any atom is more electronegative means they have more polar character with the hydrogen, right? So hydrogen atom with nitrogen and hydrogen atom in oxygen, which one is more polar? This bond is more polar because oxygen is polar. P-O-L-A-R. Polar, because the electronegativity of oxygen is higher than nitrogen. That's why OH bond is more polar. And if the bond is polar, that will help you to make more stronger hydrogen bond compared to the atom that is less electronegative. So, and primary and secondary amines form hydrogen bond which are not as strong as those of alcohols, and nitrogen is less electronegative than oxygen, that I already just explained to you. Even though primary amine, what's this? This is primary amine, right? The nitrogen is attached to just one alkyl group. This is primary amine. This is also primary amine. When primary and amine attached to the same molecule or same another amine, they're gonna form a hydrogen bond. This is hydrogen bond. Hydrogen bond. Because this hydrogen attached to this electronegative atom, and then you have one more electronegative atom from the another amine, they form a hydrogen bond, right? But this hydrogen bond is not as strong as if it was between oxygen. Let's say this is oxygen bond, and then you have one more oxygen nearby. This hydrogen bond is more stronger compared to the one between nitrogen and hydrogen in this amine molecule because of the electronegative difference. And if the hydrogen bond is not strong, then the boiling point of somewhat lower than those of alcohol. So that means the boiling point of amines are little bit lower than corresponding alcohol. So alcohol will have a higher boiling point compared to the amine, because even though both of them has hydrogen bond, right? So you all know why, because of the electronegativity difference. Tertiary amine cannot form hydrogen bond since nitrogen has now attached hydrogen atom. What does it mean? So let me show you a tertiary amine. This is amine nitrogen with 3 different alkyl group attached to the nitrogen, right? It doesn't have any hydrogen, so that's why it is a tertiary amine. If I make another tertiary amine, N, R, can they make a hydrogen bond between themselves? No, because nitrogen atom doesn't have any hydrogen attached to it. If you don't have any hydrogen on the nitrogen atom, they cannot form hydrogen bond, and because of this, tertiary amine has a boiling point similar to the alkane, because alkane also cannot form a hydrogen bond. So make sure you know the difference between primary and secondary amine, because they can form a hydrogen bond. Their boiling point is higher than alkane, whereas tertiary amine belongs to the amine group, but this is tertiary. They cannot form hydrogen bond, and because of this, boiling points are close to the alkane. That means way lower than alcohol. And also amines with fewer than 6 carbon atom are soluble in water. If we talk about whether amines are soluble in water or not, we can say amine with less than 6 carbon are soluble in water, because they can form a hydrogen bond with water. That's why they are soluble. So let's take an example. This is primary amine, right? A nitrogen, 1 R group, 2 hydrogen. If you have hydrogen atom binds to the nitrogen, and if you put another electronegative atom, you can have hydrogen bond. This is also a hydrogen bond, right? If I put one more water in here, so you have hydrogen, you can make one more hydrogen bond, right? Similarly for secondary amine, they can also form a hydrogen bond. Tertiary amine, even though it doesn't have any hydrogen attached to it, but water has hydrogen attached to the oxygen, and if this hydrogen come close to the another electronegative atom, they can form hydrogen bond, but not as strong than the primary and secondary amine, because we have 3 hydrogen bond over here, 2 hydrogen bond in amine, and there is only 1 hydrogen bond in tertiary amine. Right. Okay. Now let's talk about the many reaction that normally shown by the amine molecule. So first of all, we have to know that amines behave as a weak base. So whenever you see an amine, because we know ammonia NH3, this is as a base, And how we can make an amine? If I replace one of the hydrogen of ammonia with R group, so the property is almost same. That's why amine also behave as a weak base in water, right? And produce hydroxide ion. So let's see the reaction. This is primary amine. When you react with water, what you're gonna get? Because amine act as a base and it can take a proton or hydrogen from another molecule. In this case, water is acting as an acid and it provide one of its hydrogen to the amine, and so we can write water as HNOH. This is your water, right? HNOH, and one of the hydrogen is donated to the amine over here, right? And then what else left? This OH negative, so which is this, and then this become ammonium ion. This NH3 is ammon, so we can say this NH3 can be written as ammonium, right? Why ammonium? Because if you remember, if I have hydrogen over here, this is ammonia, and it has a lone pair on the top. It can accept a hydrogen from some other molecule, and then this lone pair is gonna remove from here, and then you will get one more hydrogen. So that means now and then you will get a positive charge on nitrogen. That we already learned from inorganic chemistry, and this entire structure we call as ammonium, because right now nitrogen has a positive charge and it bound to the 4 different bond, not 3. So this is ammonium ion, right? Similarly, when a primary amine react with water, it accept a proton from water and convert from amine to ammonia, and then give hydroxide ion. This is hydroxide ion, right? So let's take one example of this. This is methylamine. React with water. Hydrogen is given out by water to the amine, and water itself get converted into hydroxide ion, and then CH3 will get NH2 will get one more hydrogen, convert into NH3 plus, then you will get ammonium ion. So how we name any ammonium ions? You have to write alkyl name first, then this is ammonium ion, methyl ammonium. Like we have methyl amine, similarly we have methyl ammonium because of this positive and one extra hydrogen on the amine, right? The second reaction is all amine we know act as a weak base, and they form salt when they react with an acid. So we already know when base react with acid, in a neutralization reaction we form salt, right? So this is the same reaction that we are seeing over here. This is amine. When react with an acid, in this case we have hydrochloric acid, what's gonna happen? This is acid, hydrogen is being donated from hydrochloric acid to the amine. This will convert into NH3 plus, and the chlorine negative also get attached to it. So that's why this is we call as amine salt, right? Let's take an example. Methylamine react with HCl. You're gonna get methyl ammonium and then chlorine ion. So the name will be methyl ammonium. Then you have to write the negative ion name. Right. So this is chlorine chloride. Methyl ammonium chloride. Amine react with other acid to form salt, like sulfuric acid, nitric acid, carboxylic acid. So we'll take one more example. This is ethylamine. This is acetic acid, or I can say this is ethanoic acid, right? So this is an acid. We know this is base. So what's gonna happen? The hydrogen from the carboxylic acid, this hydrogen is gonna the acid is going to donate the hydrogen to the amine group. Again, you're gonna get NH3 plus and then CH3CO negative, the negative part, the anion part. This is anion part. This entire thing is attached with an ammonium ion and to form a salt. This is salt and the name will be ethyl ammonium, and the name of this CH3COO negative is acetate, or you can also write the IUPAC name as ethanoate. Right. So basically amine react show two reactions, one with water and one with acid, and with acid they form salt, right? And with water they normally donate OH negative ion, the hydroxide ion, right? Now let's talk about the amine salt that we already know how to make. So how we normally make the amine salt? We name it by changing amine to ammonium. I already told you, if you have more than 3 bonds to the nitrogen atom, they convert into ammonium, and then you have to just name the negative ion derived from the acid, right? So let's take this example over here. This is nitrogen atom. How many bonds has this nitrogen atom? Has 4. 1 2 3 4. So that means this is ammonium, because nitrogen can have 3 bonds, but over here we have 4 bonds. That means we have an extra bond, and because of that nitrogen will get a positive charge. So that's why this convert into amine to ammonium ion. So that's why we have ammonium. And you have how many alkyl group attached to this nitrogen atom? We have methyl group, we have ethyl group, we have again methyl group. So now how are we going to name it? We have to name it alphabetically. So ethyls come first, then you have 2 methyl, so that's why dimethyl. So ethyl, dimethyl, ammonium, and then you have to write at the end the anion part. We have Br negative, which is bromide. So that's how you normally name any amine salt. Similarly, let's take this example. How many how many bonds this nitrogen has? This nitrogen has 4 bonds. Why? Because if you can see, you have parenthesis and 3 is written over here. That means you have same functional group 3 times attached to the nitrogen atom, and the 4th one is hydrogen. So I can draw this structure something like this: CH2 CH3 CH3 CH2 CH3 CH2, then hydrogen, and then CH3COO negative, right? So that's why we have 3 different alkyl, 3 same alkyl group, and that's why we have tri means 3 ethyl. All the 3 alkyl groups are ethyl groups, so triethyl, and then ammonium, because nitrogen has a positive charge because it has 4 bonds rather than 3, and at the end you have the anion name, and this anion name is acetate or ethanoate. Right? So this is how we normally name an amine salt. So regarding the physical property of any ionic compound, they are white crystalline solid, more soluble in water than the parent amines, because we already know salts can make the organic compound more soluble compared to its original parent chain because of the ionic nature of the salt, right? We have positive and negative ion. Okay, so till now we just saw the reaction of amine with an acid or water. Now we'll see how the amines can be reacted with a strong base, or not amine, how the amine salt are going to react with a strong base. Now we are going to use a salt. So let's take this example. This is one salt, which is alkyl ammonium chloride, react with a base this is base, sodium hydroxide. So the reaction says whenever you add a strong base on amine salt, you can convert back the salt to amines. You are reversing the reaction, right? So you are converting salt to amine now. So over here you're gonna get RNH2 group, water and salt, NaCl, right? So this is your NaCl, and one of the hydrogen from ammonium ion is going to donate it to OH so that they can make water. And how many hydrogen left now? Just only 2, because one of the hydrogen is already donated to OH group of the sodium hydroxide, and then the rest of the hydrogen is still attached to the nitrogen. So this is an amine, RNH2, right? So how you can make amine back from its salt? By reacting with a base. So now let's talk about how amines reaction, or if I put an amine in a solution, then this pH determine which form of the amine is present in a solution, whether it's just amine or ammonium ion. So depending on the pH of the solution, which is also called as hydronium ion concentration, means H plus ion, how many hydrogen or protons are present in a solution. So let's take an example. This is an RNH2, this is amine, right? And if I put this amine in a solution that has high H plus ion present, that means low pH. Lower the pH means higher the concentration of H plus ion, means more H plus are present. So if you have more H plus ion present to react, it will react with amine and form NH3 plus, because you have more number of H plus ion in the solution. But whereas if you change the pH from low pH to high pH, now let's assume, that means you are decreasing the H plus ion in the solution. So if you don't have enough H plus ion in a solution, the reaction will go backward and convert NH3 to NH2, and then you will get 1 H plus ion as a product, right? So depending on the pH, you will know which form of the amines are present, whether simple amine or ammonium ion, right? Right. So this means you can find amine at high pH when you have low H plus ion, and you will get amine salt when you have low pH, means high number of H plus ions are present in a solution, so that it can react with NH2 group and convert it NH2 to NH3. So make sure you remember how the pH affect the structure of the amine, right? Whether you're gonna get salt or just amine. Now let's talk about the quaternary ammonium salt. We already know what is salt is when all the four, this is R, this is H, and then you will have some anion part, chloride, bromide, right? So in this case, this is salt. So for this salt, on this nitrogen, out of the 4 bonds, this nitrogen can make 3 are alkyl group or aromatic compound, and one of the bond is attached to the hydrogen, right, in this particular form of the salt that we have been discussing till now. But if I remove the 4th bond of the hydrogen by an alkyl group again, then we call that salt as quaternary salt, because this nitrogen doesn't have any more hydrogen attached to it. All the 4 bonds are replaced by alkyl group. In this case, ethyl, ethyl, ethyl and methyl, right? So if all the bonds of the nitrogen get replaced by an alkyl group or any aromatic group, that salt normally we call as quaternary ammonium salt, right? This is positive sign. And remember, in quaternary ammonium salt, we don't have any bond attached to the hydrogen. Nitrogen is not bonded to the hydrogen atom. Contain no hydrogen attached to the nitrogen that can be removed by adding a base. So if you don't have any hydrogen atom attached to the nitrogen in quaternary ammonium salt, and if they react, this quaternary ammonium salt react with a base, even though you are reacting with a base, this salt doesn't have any hydrogen. That means it cannot provide a hydrogen to the base. So that means it doesn't affect the structure of the quaternary ammonium salt, whether you add base or an acid on it, right, which is independent of the pH of the solution. So you will always get the same kind of structure, doesn't matter what the pH of the solution is, because we don't have any hydrogen. So make sure you know this difference too. And the name for this particular salt is triethyl, because you have 3 ethyl group attached to the nitrogen, then you have methyl group, ammonium chloride, right? Okay, so now let's talk about a second functional group for this chapter, which is amide. So how we normally form amide? When amine react with an acid chloride or an acid anhydride, or we can also say when amines react with carboxylic acid, right? So we'll see later on which process is more favorable to make an amide, whether amine react with carboxylic acid or amine react with acid chloride or acid anhydride. The characteristic functional group is carbonyl group attached to the nitrogen atom. So how does this group looks like? So you have a carbonyl group, and if you have this carbon, out of the 2 bonds on the carbonyl group, if one of the bond is attached with nitrogen, we call that as amide group, and this bond we call as amide linkage. For example, if you have C double bond O NH2, this is your amide group, and this bond between carbonyl and nitrogen we call as amide linkage. Right. So the amide linkage is carbon and nitrogen single bond of the amide group, right, that we just explained. So now if we look at the amide group, we can say this amide group comes from 2 functional group. One of the group which is carbonyl group, that comes from the carboxylic acid part, right, and this N group comes from either from ammonia or from amine, right. So let's take an example over here. We have CH3 C double bond O OH, and if you react with ammonia, which is NH3, what's gonna happen? This is a reversible reaction. So what's going to happen? OH from the carboxylic acid and 1 hydrogen from the ammonia is going to react and convert into water, right? And what about the rest of the molecule? So you can get CH3 C double bond O and then NHH, right? Everything just stick together after we remove water. So this bond called as amide bond, formed by reaction of ammonia with carboxylic acid, right? So that's how we normally show over here. The carbonyl group comes from the carboxylic acid, because this is this, and this nitrogen comes from either ammonia or amine. In this case, the example that I showed you, this amine NH2 group comes from ammonia. Okay. So let's take one more example. If I have CH3 C double bond O OH, now if I'm going to use NH2R, or let's say CH3. This is methylamine, right? This is ethanoic acid. When these two react, let me show the product over here in the down. So what's going to happen? This OH from the carboxylic acid and one of the hydrogen from NH2 is going to react and come out as water. Now the rest of the molecule going to stick together and you will get CH3, C double bond O, then N, and on the nitrogen one of the hydrogen is removed, but still we have one hydrogen left, so hydrogen, and then you have CH3 group, right? And then you're gonna get this amide bond, amide group, and this bond is your amide linkage, amide link or bond, right? But it has to be noted down, reaction of amine with a carboxylic acid normally produces salt, not an amide, in the right condition, right? So that's why we normally use an acid chloride or acid anhydride to make an amide compound, right? But the reaction will be exactly the same that I just explained to you. So now we're gonna see how we form an amide formation, amide compound from two different compound, right? An acid chloride or acid anhydride, but you can also make from carboxylic acid too, but that's not the right way of making a amide bond, because those reactions are reversible and they normally don't give enough amount of amide bond or amide compound. But if you see carboxylic acid react with amine or any ammonia, you can easily form amide bond, even though that one is not the right way of doing it, but still you can make an amide bond or amide compound that I already explained in that last slide. So now let's go to the two reaction, one with acid chloride, one with acid anhydride. So primary, secondary amine can be used for the preparation, while tertiary amine we cannot use to form an amide. We'll see later on why the tertiary amine cannot form an amide bond or amide group. So let's start with the acid chloride. In carboxylic acid chapter we already know what is acid chloride. This is acid chloride. When react with amine, which type of amine is this one? Primary amine. So this Cl from the acid chloride react with one of the hydrogen. In this case, let's assume this is the hydrogen. They come close together and then come out as an acid, hydrochloric acid. Now rest of the molecule is going to stick together. What else is left? We left with RCOO, which is this RCOO, and then we left with N R. So the nitrogen is going to attach with carbonyl group, and then you have one R group attached to the nitrogen, one hydrogen over here, right? And then once you make this product, this is your amide functional group, and you're gonna make one amide, right? So basically you have to just take out, when we react with acid chloride, you have to take out an acid from the reaction and then stick the other remaining molecule, right? As long as you have one hydrogen attached to the nitrogen atom, if you have at least one hydrogen attached to the nitrogen atom, they can react with acid chloride. If you don't have any hydrogen atom attached to the nitrogen atom, especially in the case of tertiary amine. What is tertiary amine? this is N, this is R, R. So this is your tertiary amine. It doesn't have any hydrogen attached to the nitrogen, right? We don't have any hydrogen. If we don't have any hydrogen, it's not gonna react with chlorine from the acid chloride to form an acid and then form an amide later on, right? So that's why tertiary amine cannot react with acid chloride to form an amide, because that tertiary amine doesn't have any hydrogen, right? If we talk about the secondary amine, what is secondary amine? Nitrogen, you have R group, and then you have one hydrogen. So in secondary amine, still you have one hydrogen left that can react with the chlorine or any chloride of the acid chloride and remove an HCl. So that's why primary as well as secondary amine can react with acid chloride to form an amide, but not the tertiary one, right? So make sure you know this difference. Now let's try the second way of making a amide bond from acid anhydride. In the last chapter I already told you this is anhydride group, and when we have an amine group attached to it and when we react with amine, what's gonna happen? Then this hydrogen, this bond is going to break, and one of the hydrogen is going to attach with this oxygen, and the nitrogen is going to attach with this carbon, and you will get RCOO plus this entire nitrogen atom, NHR, and then the hydrogen from this amine going to get with this oxygen, and then you're gonna get an carboxylic acid, right? So that's how you're gonna make an amide bond or amide group in there, or with an amide linkage, right? This is your amide linkage or amide bond. So make sure you practice this kind of problem to make an amide. So let's take a couple of examples of amide formation. So first one we are using as anhydride group. So this is anhydride group, C double bond O, C double bond O with an ammonia. In this case we are not using amine but we are using ammonia, so we have 3 hydrogen. So one of the hydrogen is going to remove, and then this bond is going to break, and this hydrogen is going to attach with this oxygen, and this nitrogen, this entire group with a nitrogen is going to attach with carbonyl group. So that's how you're gonna get CH3 C double bond O with nitrogen to 2 hydrogen atom, right? And this atom that is gone to the oxygen, they're gonna make a carboxylic acid group, right? So by using the same principle, let's take one more example. We have one acid chloride, means we have carbonyl group with chloride atom, right? Where we are reacting this acid chloride with primary amine. So you have nitrogen, you have 2 hydrogen, 1 alkyl group. So chlorine from the chloride, acid chloride react with one of the hydrogen from the amine and convert into HCl, H plus Cl, HCl, and then the rest of the molecule is going to stuck. This nitrogen, this entire molecule group is going to attach this carbonyl group, and then you will get NHCH3. Right. We're gonna see how we're going to name this amide later on, but right now make sure you know how we can make the product. Similarly, one more example, again acid chloride, and then you have secondary amine. In this case, means out of the 3 bonds, 2 bonds is replaced by the alkyl group, and you still have 1 hydrogen. That's why the reaction is possible. So hydrogen react with chlorine, remove as an HCl, and then the rest of the reactant is going to stick together, and then you're going to make benzene plus C double bond O, and then nitrogen with 2 alkyl group, nitrogen with 2 alkyl group, right? And then this is your amide linkage, this is your amide bond, right? So make sure you practice all this problem from the previous slide as well as on this slide. Okay, so now let's try to name an amide, an organic compound that has a amide bond or amide linkage. So the rule will be exactly the same. You have to give the priority to that carbon that has the amide group, right? So let's take, this is your amide group, CONH2, right? And this is the carbon that you have to give the priority. So you have one carbon. If you have one carbon, then what's the name? Methane in this amide group. And always remember, the ending word will always be amide. So in this case, methane amide, because we are talking about amide, right? Let's take this example. This example over here. So the time I see C double bond ONH2, and we know this is what, benzene ring. So we write, and this product is going to come from benzoic acid. So this OH is going to replace with NH2 group, right? This is happening. So we write benza amide. So benza means benzene, and amide, you have an amide group on the benzene, so that's why it's benza amide. Let's take one more example. If I have CH3, CH2, CH2, C double bond O NH2. What's the name of this molecule? The time I see C double bond O NH2, I know this is amide, and I have to give the lowest number to this amide and to the carbon that has this amide. So this is number 1 carbon that is a part of amide group. So you have to specify this carbon as number 1. So make sure you don't do a mistake and by mistake use this carbon, the adjacent carbon of the amide bond, or use as number 1 carbon, right? So you always have to use the carbon from the amide bond. So this is 1, 2, 3, 4, and then if you have 4 carbon, we know this is butane, and if it's butane and then this is amide, the ending word will be amide. So butanamide. So now let's try to solve some more problem of how to name an amide. So the second rule is, if an alkyl group is attached to a nitrogen atom of the amide, you have to use an etadial word or prefix N, right? It's the same thing that we use in amine. So let's try to solve some of the naming based on this rule. So this is an amide. The time I see C double bond O NH, I know this is an amide, right? So you have to give the priority to the carbon that of the amide group. So this is the carbon that's comes from the amide. So you have to give the priority to this carbon. So this is 1. So this is 1. So how many carbon you have in this entire molecule? You have 1 carbon, which I already assigned number 1, but you have 1 more carbon, which is this, and this carbon is not the part of the parent chain or in the part of the numbering of the parent chain, the longest carbon chain. This alkyl group is attached to the nitrogen and it's not the part of the parent chain. So that's why whenever you have any alkyl group that is not part of the parent chain and it attached directly to the nitrogen, you always assign a prefix called N, and then you have to write N-methyl, and then in the parent chain how many carbon you have? Just 1, right? So 1 is methane, and then this is an amide, methanamide, right? So N-methyl methanamide. So let's do one more example. The time I see this, I know this is amide. You have to give the preference to the carbon of the amide group. So this is 1, this is 2, but still you have 2 more carbon, that is not the part of the parent chain, which is this, and it attached to the nitrogen atom directly. So again you have to specify that you have two alkyl group that is not part of the parent chain but attached to the nitrogen atom itself. So N comma N, so you have two alkyl group attached to the same nitrogen atom and they have same alkyl group, so that's meant dimethyl. And then how many carbon you have on the parent chain? 1 2 2 is ethane, so ethane amide. Right, so this is the way of writing the name if you have alkyl group attached to the nitrogen atom. So let's take one more example. If you have benzene and if you have C double bond O N, you have CH3, this is CH2 CH3. So this is your first question. Let's do the second one. You have CH3, or let's do for benzene this time. Again this is your benzene ring, it's C double bond O, you have NH CH3, then you have CH3 in here. So let's try to solve these two compounds and try to name it. So let's start with the first one over here. So the time I see I have C double bond O N in the structure, we know this is amide, right? So you have to first figure it out which functional group you have in organic compound. So this is amide and then this is benzene, so I know that name will be what? Benzamide. That's our parent chain, right? But we have two alkyl group attached to the nitrogen atom. One is this, which is ethyl, one is this, which is methyl. So we have to use a prefix called N comma N, or not we have to use alphabetical order. So we have to write N, ethyl comes first, N ethyl, then we have to write N methyl benzamide, right? So this is the name N ethyl and methyl because we are specifying that both the alkyl group is not part of the benzene ring, but they are part of the nitrogen compound, nitrogen atom, right? They are attached directly to the nitrogen atom. Let's do the second question that will really help you to understand the first one too, why we are rewriting N. So let's do this one. The time I see C double bond O N, I know this is amide and we have to use an amide nomenclature, the rule for the amide. So and the time I also see we have a benzene ring with an amide group, benzene plus amide, we know this is also benzamide, right? But what's the difference from the first problem over here? Over here you have two alkyl group, one of the alkyl group is attached to the benzene carbon. If you see over here, it's not attached to the nitrogen atom, it's attached to the carbon of the benzene, right? And second alkyl group is attached to the nitrogen atom. So you have two alkyl group attached to two different atoms. So how are we going to name it? So we have to specify a number on the benzene ring, and then you have to use the carbon number 1 as that carbon that has the amide bond or amide group attached. So this is 1, this is 2, this is 3, 4, 5, 6. So I can write 3 methyl and methyl benzenamide, right? So you are specifying you have one methyl group which is present on the benzene ring on my bed. This is 2, not 3. So let's change this 3 to 2 because this is second carbon. So 2 methyl and methyl, so this is N methyl benzamide. Let's do the third one. If you have CH3, C double bond O, and CH2, CH3, CH2, CH3. So the time I see this is amide, and then you have two alkyl. You have to make sure you have to give priority to the carbon of the amide bond. This is 1, this is 2. We cannot go right hand side because we have nitrogen. That's why this is our parent chain 1 and 2. You have 2 carbon, so I can say the parent chain will be ethanamide, right? And now you have 2 alkyl group attached to the nitrogen atom, which is not the part of the parent chain. So I can say, and both of them are ethyl, if you can see. So I can write N, N diethyl in this case, ethanamide. Right. So make sure you practice all this type of problem. So now let's talk about the physical properties of the amide again, whether the amide can form a hydrogen bond with themselves or not, or whether amide can be soluble in water. So let's talk about first whether they can make a hydrogen bond with themselves. So one amide molecule can form a hydrogen bond with another amide molecule. So formamide is the only unsubstituted amide that is liquid at room temperature. Complex hydrogen bonding between unsubstituted amide cause them to have high boiling point. Means why they have a high boiling point? Because they can make more hydrogen bond, a stronger hydrogen bond. So let's see, you have one amide molecule in here, so CON, and then on the nitrogen you have hydrogen atom. If I put another amide molecule underneath it, so the carbonyl group of one of the amide group and the hydrogen from the second amide group come close together and they form a hydrogen bond. This is your hydrogen bond. Similarly, you can have multiple hydrogen bond if you have multiple amide molecules side by side, and because of this they have a high boiling point because they can form a hydrogen bond. Amide can also be soluble in water because they can form a hydrogen bond with water, but only 6 carbon or less carbon containing amides are soluble in water. If you have more than 6 or 7, it might not be as soluble as it was when you have only 6 carbon. So let's take an example. This is water. The hydrogen from the water can form a hydrogen bond on the carbonyl group oxygen, right? This is your hydrogen bond. Then again on the same amide molecule you have one hydrogen attached to the nitrogen. Then if you put one water molecule side by side, they can form a hydrogen bond. So that means you have 2 regions of hydrogen bond. One is on the carbonyl group of the amide that can form a hydrogen bond on the hydrogen atom from the water molecule, and the second hydrogen bond the amide can form between the hydrogen atom and then the oxygen atom from the water molecule. And then you have one more hydrogen attached to the nitrogen. They can make a hydrogen bond with the oxygen atom of the water molecule. So that means you can make 3 hydrogen bond with water if you have one molecule of primary amine. So this is primary amine because you have 2 hydrogen. If it was a secondary amine, what's gonna happen? So you will see over here, the time I see this is a amide bond, right? And this nitrogen of the amide bond, out of the 3, 2 are replaced by the alkyl group, and you just have one hydrogen. So this is a tertiary amine, right? So tertiary amine means you don't have any hydrogen attached to the nitrogen atom. So that means the only way they can form a hydrogen bond is from the carbonyl group of the amide and hydrogen atom from the water, right? And the second one they can form is the hydrogen atom from the oxygen and nitrogen atom from the amide bond. So you have 2 hydrogen atom, right? So basically they can form a hydrogen bond with the water, so that's why they are water soluble, right? So now let's talk about the amide reaction. So first of all, amides are neither acidic or nor basic. What does it mean? So what is amide? Amide is C double bond O NH2. So because of this structure of the amide group, the carbonyl group that you have in the amide normally destroy the basicity of the amine group. Because of the presence of the carbonyl group near to the amine NH2 group, they destroy the basicity of this original amine, right? So that means they are not basic. Whereas because this nitrogen attached to the carbon, right? So what is carboxylic acid? OH. Because you remove this OH from the carboxylic acid and replace with NH2 to make an amide bond, the acidity of the carboxylic acid or this carbonyl group is lost. So that means each of them is destroying their acidic and basic nature. So that means amides are neither acidic nor basic because of the structure they have, right? The carbonyl group bonded to the nitrogen destroy the basicity, and the nitrogen atom of the amine replace the acidic OH from the carboxylic acid group. So they neither is acidic nor basic. So the reaction that we're going to talk about is amide hydrolysis. So hydrolysis is breaking a bond in the presence of water when you break any bond. So the reaction says amide is cleaved to produce carboxylic acid and amine or ammonia, right? So let's try to see one reaction over here. This is amide. The time I see this is amide bond or linkage. So this bond is going to break during hydrolysis reaction or amide hydrolysis. So what's gonna happen? You can write H and OH. This is water. So what's gonna happen? The OH from the water is going to go to the carbonyl group and hydrogen is going to go with nitrogen. So that's how you're gonna make a carboxylic acid, and then this will become NH2, right? Because it's getting one extra hydrogen. So right now is NH. If you put one more hydrogen, that's become NH2. And if this nitrogen attached to an R group as a third bond, then this is amine. But if this R group, if this R group is replaced with an hydrogen, that will become ammonia, right? So depending on what this R group is, whether this is hydrogen or any R group, your product can be amine or ammonia, but one of the product will always be a carboxylic acid, right? Okay, so remember this thing. During amide hydrolysis, in the presence of water, you're gonna get two products. One will always be a carboxylic acid. Second one might be amine or ammonia, and you always break this amide bond. Let's do some more example. This is called acid hydrolysis. What is meant by acid hydrolysis? Means in the presence of an acid, you are using water to break that amide bond, right? So again the same reaction, HOH, this is water. So what's gonna happen? OH will go to the C double bond O, H will go with NH2. So what you're gonna make? NH3. Now this will become NH3, and then CH3COO negative will become acetic acid or ethanoic acid, because the OH comes from the water molecule. But this ammonia that you are making by putting an extra hydrogen to this amine NH2 group, and you also have a HCl, this is acidic. This ammonia that you're going to make is basic. That means this hydrogen is also going to go to this ammonia. So the reaction won't stop. You will get the final product as NH4 plus, because an extra hydrogen is still coming from an acid, and then you're left with Cl negative. So the name will be ammonium chloride. So you always get a salt, right? Similarly, let's try to solve this problem over here. you have N-methyl ethanamide. Instead of acetamide, the IUPAC name will be ethanamide, because you have 2 carbon, 1 2, right? This is methyl group, N-methyl ethanamide. So let's try to see this reaction over here. We have water HOH, right? The OH will go to this carbonyl part, hydrogen will go to the nitrogen part. So what you're gonna get? You can get one acetic acid or ethanoic acid. And then once this N group receive a hydrogen, it's gonna make, and this bond is going to break. So you're going to get methanamine. Okay, CH3NH2. But because you are working in the presence of an acid and amine will be a base, this hydrogen from the acid again go to the same nitrogen. So right now you have CH3NH3 plus, and then you're left with Cl negative, right? Methyl ammonium chloride. So that's why you are getting 2 different products. I already explained how they are going to make and why you have 2 different products. Let's do the third reaction. When you react an amide in the presence of a strong base. This is a strong base, sodium hydroxide. So what's gonna happen? This NaO part is going to go with C. This bond is going to break, and this hydrogen, leftover hydrogen, goes to the nitrogen. So you will get CH3C double bond ONA, and then the second product will be CH3NH2, because the hydrogen is moved to the onto the NH group. So now you have NH2, right? So whenever you react an amide with a strong base, you always get a salt, and we already know how to name a salt. This is sodium. Instead of acetate, which is a common name, we can write ethanoate, right? And this is amine, the second product. So make sure you know the difference when you do a hydrolysis in the presence of acid and when you react amide with a strong base, what should be a product. So practice again these type of problems. And I think that will be it from this chapter.